Morning, I'm Shankaran. Good to see you after so many months, actually. Okay, because there was a bit of an emergency and bit of an involvement on the family side, I was not able to speak to you. Good. So we are going to speak about what is called as a cryptographic lineage tracking. Okay, so the artificial intelligence. Okay, when you look at the risk of the artificial intelligence we have in 2894, that speaks about the complete risk. It's ISO guideline. Surprisingly, not many people are aware that there's a guideline for risk for AI. Okay, 2894 is actually the guideline. We deliver the training on the lead risk manager and also CAI or the AI risk officer. Now, coming on this particular one, the cryptographic lineage tracking. Okay, now what actually happens is the sometimes you get a model or a data from through supply chain. So it's like you're booking in the food in Zomato or Calabar. Okay, so the ingredients comes from a different supplier, and they source it from different supplier. Okay, so finally the food is actually prepared, comes to you. Similarly, in the AI, okay, when you are actually buying a model, the model might get the algorithm, okay, from a different supplier, and the data set from different supplier. Okay, and the data set which is supplied to the supplier might be sourced from a different supplier. Okay, so the chain goes on until you actually get your AI application. Okay. Now there are three binding components whenever it comes to the artificial intelligence. Okay, one is the data set, the other one is the algorithm data set, and the algorithm is going to give you the model, and there's actually a binding code. Okay, the output of the AI also is the model, which is going to be the part of the SDLC. This is what the complete ecosystem for the AI application is. Now, for each and every component that is involved on AI application, we need to find, okay, if at all it's from a third party, we need to find out from where it is actually getting sourced. Okay. Now, in the cryptographic lineage tracking, what actually happens is an organization is going to have the data set, they will calculate the hash value. Okay, so they will give it to one company. Okay, and the algorithm, okay, will be from another supplier. Okay, and they will also have an hash value, and it contains that. Okay, now every single layer it goes up and up. Okay, it contains the hash value. Now, on the layer one, the data set and the hash value, and algorithm and the hash value. Okay, and when you're packaging it, okay, so you will get the model. When you're shipping the model, you'll have the hash value of the supplier A who has given you the data set, the supplier B who has actually given you the algorithm. Okay, you'll when the model is actually generated, okay, you will calculate the hash value of the model, and when you're calculating the hash value of the model, you'll have the hash values of the data set as well as the algorithm as a part of it. Now the model and this package goes to the next stage where the application is being developed. Okay, so the application uses the model. Okay, the hash value is separate part of it. Application uses the model, and the complete AI application is actually built. But when they calculate the hash value of the application, okay, it includes the hash value of the model, which includes the hash value of the data set and algorithm. Okay, this is actually called the cryptographic lineage. Okay, lineage stacking. When as and when it progresses from the foundation level to the topmost level, okay, if there is going to be a deviation anywhere, okay, you can actually find out that okay somebody has tampered it. If the algorithm is tampered, the hash value will change. If the data set is tampered, the hash value will be changing. If the model is tampered, how the model tampering can happen? The serialization, deserialization. Okay, the hash value will actually change. An application will, okay, the EXE, you can calculate the hash value for literally any type of file. Okay, and if it's going to be an modification, unauthorized modification, you can actually find it out. In fact, you can club this to a file integrity monitor with the SIEM. As and when there is a change, it'll trigger an alert on the SIEM. The SOC team will get involved. Okay, that's a different code with respect to security. Now, cryptographic lineage tracking is exactly what the same concept is there in cryptography, wherein if you look at the public infrastructure, okay, there's a sender A and sender B. Sender A is going to form the message, and you calculate the hash value of the message, encrypt the hash value as private key, okay, and then encrypting the hash value of the private key is actually got as a digital signature, a cryptographic signature. The message, the digital signature will be encrypted by the recipient's public key, and you'll send the message to the recipient. He'll use a private key to decrypt it. Okay, then he'll get the digital signature and the message. Digital signature is nothing but the encryption of the hash value with the sender's private key. You can pick up the public key and digital certificate, decrypt it, and there's a flow. So this combines the digital signature, okay, the PKI, okay, digital certificates, okay, this the principle, as well as the chain of custody. Okay, so cryptographic lineage tracking is very important for third-party security whenever you're going to implement, whenever you're going to implement security as part of the AI, and it involves a third party. Okay. So thank you very much, Subramaniam Shankar. I'll give you my email ID, and then you can join us for the certified chief AI officer, auditor, security officer, risk officer. We'll ensure that all these trainings are as simple as possible to ensure that you gain the most of the knowledge out of this. Thank you very much. Cheers. Bye-bye.